seen lots of videos on the internet for preparing fuming nitric acid, but we thought we'd go a step further and do something we'd not seen. First we start with 35 grams of potassium nitrate. We broke this down into a very fine powder, and we just need to break up the lumps that have formed in storage to form a free-flowing powder. Transfer this into a 250 ml round-bottomed flask. We're hoping that having a fine powder will help us get a good yield in this first step. Now measure out 21 ml of 98% concentrated sulfuric acid, and add this to the potassium nitrate powder in the flask. The mixture will rapidly become quite warm. Using a glass rod, stir the mixture around in order to get it to mix thoroughly. From the heat generated by the reaction, you can already see some reflux beginning inside the flask. This is nitric acid. Set up immediately for distillation. No need to use a thermometer, as we just want to distill off all the liquid up to around 100 degrees C. It is important to use all glass joints, however, as the nitric acid vapor is extremely corrosive. Soon after heating, we can see some boiling in the flask, and pretty soon we see some vapor coming off along with some brown nitrogen dioxide gas, which is produced by nitric acid decomposition. Use ventilation, as these fumes are highly toxic. Soon we see vapors condensing in the adapter, and distillation commences. Note how the nitric acid vapor, as it rises and the adapter, is colorless and not brown colored. A yellow liquid starts to condense in the receiver. This is pure nitric acid, but has a yellow color due to some of the brown nitrogen dioxide gas dissolving in it. Towards the end of the distillation, the contents of the still pot becomes a solid cake. The speed of distillation also slows down. Complete distillation takes quite a long time, so it's up to you when to turn off the heat. Towards the end, as the temperature rises, you can see more nitrogen dioxide decomposition product. We stopped heating around this point. Here's our product: 17.7 grams of pure nitric acid. This is an 81% yield on starting potassium nitrate. It's a yellow color due to dissolved nitrogen dioxide, but is still relatively light in color. In moist air, the liquid fumes strongly, hence the term fuming nitric acid. Don't forget that your reaction flask now contains a cake of potentially useful potassium hydrogen sulfate. We'll save this and use it for another reaction. We wanted to experiment and see if it was possible to create nitrogen pentoxide. So we set up a 100 ml flask in an ice bath and added around 10 grams of the fuming nitric acid we prepared. We then weighed out 20 grams of phosphorus pentoxide. This is more than we need, but we wanted to be sure that we'd converted all the nitric acid present. Slowly and with stirring, we added the solid phosphorus pentoxide to the nitric acid. On addition, the mixture hissed and produced some heat and some brown vapor. The mixture became increasingly viscous during the addition until it was a thick syrup. At the end of the addition, we'd clearly added in excessive pentoxide, as you can see here. We didn't want to distill the mixture due to a risk of an explosion, so we gently heated the flask on the water bath. Just before 40 degrees, we noticed that the mixture became much more liquid and was starting to decompose into nitrogen dioxide gas. We also started to see some liquid refluxing on the sides of the flask. And this is it, nitrogen pentoxide, which melts around 40 degrees and boils around 46. We used a petri dish containing ice cubes to see if we could condense some, a colorless liquid, fuming in air, and evaporating off the dish almost instantaneously. It could be nitric acid, but it did evaporate into thin air. We attempted to see if it would react with ethanol, but we just couldn't do it fast enough. We also tried to mix some of the flask contents with a little cane sugar. But it didn't want to react. So, not wanting to disappoint you, we dripped some ethanol into the flask. Pretty much the same as the nitric acid reaction. So we'll leave you with this, our best evidence. A solid which melts and then refluxes between 35 and 45 degrees C. Thanks for watching.